Okay, so we have our structure of the exam. So first problem that's a good one to look at here is example problem 4 from the practice problems. All right, so our setup here, we're given information about two different angles. And then we're asked to find the sine of alpha plus beta. So we need to know the formula for alpha plus beta, sine of alpha plus beta. And that's going to be on the formula sheet on the front of the test. So just write that down. And that is sine alpha cosine beta plus cosine alpha sine beta. So I know the sine of alpha, but I need to figure out the cosine of alpha. So sine of alpha is 1/8. And alpha is in between 0 and pi over 2. So that puts it in quadrant 1. So I extend an arbitrary line into quadrant 1 and then drop the vertical back to the x-axis, label the angle alpha. And now we're just going to fill in what we know. We know the sine of alpha is 1/8, some old hippie O over H. So that is 1 here and 8 up here. So we need to solve for the third side so we can label what the cosine of alpha is. So Pythagorean theorem, x squared plus 1 squared equals 8 squared. So we end up with x equals plus or minus the square root of 63. Now, since we're in quadrant 1, x is to the right, so we are going to keep the positive square root of 63. And that means the cosine of alpha is square root of 63 over 8. Now, same song, second verse, but we're going to do it with the beta. Now, the beta angle is a little more interesting. Cosine of beta is -1/2. And we're told beta is between pi and 3 pi over 2. So pi is to the left, 3 pi over 2 is down. So this puts our triangle in quadrant 3. And now caught another hippie adjacent over hypotenuse. So -1 for the adjacent side and 2 for the hypotenuse. And now Pythagorean theorem for that third side. I'll call it y. So -1 squared in parentheses is +1 plus y squared equals 4. And then we minus the 1 and we have y squared equals 3. And then we square root both sides. And we have the plus or minus question. So when I look at the triangle, the y side is going down because it's in quadrant 3. So we're going to keep the negative square root. And now that I know that opposite side, I can fill in what the sine of beta is. The sine of beta is negative square root of 3 over 2. So now I know all four pieces I need. I just need to fill in the pieces in the formula and I'm done. So sine of alpha is 1/8. Cosine of beta is negative 1/2 plus cosine of alpha square root of 63 over 8 and sine of beta negative square root of 3 over 2. Now you can multiply if you want, but you can type in that right there and WebWork will take it, and I will take that on the test. One sec, my Zoom is being weird. So I know whether I'm choosing the positive or the negative based on which quadrant the triangle is in. So when I got to y is plus or minus the square root of 3, I looked back at the quadrant I drew the triangle in. In quadrant 3, the y direction goes down, so that's negative on the y-axis, so that's why I picked the negative square root. In our first example with alpha, we were in quadrant 1. X is to the right, that's the positive x-axis, so that's why we picked the positive square root. So it's just like what's positive and what's negative in that quadrant. So quadrant 1, X and Y are both positive. In quadrant 3, X and Y are both negative. And then quadrants 2 and 4, one's positive and one's negative. Now on the test, after you answered this question, there's going to be a follow-up question that asks, what's the sine of 2 beta? So our formula sheet tells us that sine 2 theta is 2 sine theta cosine theta. So when I'm looking at sine 2 beta, then this will be 2 times the sine of beta times the cosine of beta. Well, I know what the sine and the cosine of beta are, so I'm just going to fill those in. So the problem is going to give you 2 angle setups at the start. You're going to have to draw the triangles for both, Pythagorean theorem, double check that you're using the right positive or negative. The first part asks you for a sum or difference. The second part asks you for sine of 2 theta, one of the angles. All right, I'm gonna have to restart my Zoom, I think. Or So on this question, you do need to leave it as exact values. You can't just shorten it to the decimals. Yeah, the follow-up is how the double angle question will be formatted. Sorry, I'm having to shorten my Zoom is not displaying the chat window for me. So it's being annoying. So I'm having to like resize the screen to see the chat window. So it's going to be a little weird. All right, we had a request for some polar questions, so let's hop over there next. So practice problem number 20 is a good example for the first part of the polar question. So we have find the polar coordinate with negative pi over 2 less than theta less than pi over 2 for the following Cartesian coordinates. And then they tell us if x, y equals negative 8 comma 5, then r theta equals blank. So for our polar formulas, there are 4 of them. We have x equals r cosine theta, y equals r sine theta, x squared plus y squared equals r squared, and tangent of theta equals y over x. So I know x and y. I need to figure out r and theta. So I want to use a formula that uses x and y and r, and that is my x squared plus y squared equals r squared. All right, so x is negative 8, so I have negative 8 squared plus y is 5, so plus 5 squared equals r squared. Negative 8 squared is 64, plus 5 squared is 25. So we get r squared is 89. And then we square root both sides. And we have that plus or minus question. Now, right now, we're just going to leave it at plus or minus. We'll decide whether we want the positive or the negative after we figure out our angle and compare it to where the coordinate point is. So to figure out our angle, we're going to use the formula that relates the angle with y and x using the tangent function. So tangent of theta equals y is 5 over x is negative 8. Should have left some space. To get rid of the tangent function, we're going to apply the inverse tangent function on both sides. And then this is something I'm going to type on the calculator. So the inverse tangent of 5 divided by -8. And initially, my calculator spits out -32.005. Now I'm putting a question mark by that because the original problem's qualifications were that theta needs to be between -pi/2 and pi/2. -32 is a degree number, not a radian number. So to get the correct angle number here, I need to make sure my calculator is in radians mode. In radians mode, this number is 0.558599, blah, blah, blah. So we got a negative angle. So it's about -32 degrees. So -32 degrees is somewhere in quadrant 4. But where is the ordered pair that they gave us? Yeah, -8.5 is in the second quadrant. Now my angle, the -0.5585 radians, that is between -pi/2 and +pi/2. So I can't change my angle. So the only thing I can change now to get the correct polar coordinates is to choose which radius I need. So I'll end up in quadrant 2. So with my angle where it is right now, if I picked a positive radius, I would move forward into quadrant 4. But that's not where my point is. My point is backwards in quadrant 2. So our r theta point has to use the negative square root of 89. And then that negative decimal we got. Now, equivalent polar point would be if I added pi to the -0.55. And I could use the positive radius then. But pi is 3.14. If I add 3.14 to -0.55, I'm going to be bigger than pi/2. So that would put the angle outside our qualification for theta. So this is the only ordered pair that follows the requested qualification. Okay, so to pick between the positive and the negative radius. So our angle being -0.55 or -32 degrees, like just thinking about how our angles lay out on the unit circle. Counterclockwise is positive angles, clockwise is a negative angle. So -32 degrees, we go clockwise a little bit and we're in quadrant 4. So when we're doing polar points, we rotate to the direction we're being told, and then we move our radius number. So if our radius is positive, we move forward in the direction we're pointing. If the radius is negative, we move backwards away from the direction we're pointing. So my angle has to be the -0.55, the -32 degrees. But I want to move to this point in quadrant 2. So I'm stuck facing quadrant 4. If I go with a positive radius, I'll move forwards into quadrant 4. That's the wrong quadrant. So I have to use the negative radius. That'll force me to move backwards. So I know polar points are weird, but I literally think about it as being on a swivel chair like I'm on now. So the first thing is I rotate to the angle they told me. And then I think about, am I going to scoot forward or am I going to scoot backwards? So if I think about like physically doing the move myself, that sometimes helps make polar make a little more sense. It is still definitely weird. Did that help some? So we used tangent theta equals y over x because this was a formula that used y, x, and tangent. Like we did have the radius, but we didn't know if it was the positive or negative radius. So that's why I didn't use the first two formulas. Because knowing whether it was positive or negative, like would change the theta values that I would get in there. The tangent theta equals y over x formula already follows the restrictions that they put on theta. Inverse tangent only spits out angles between negative pi over 2 and pi over 2. So that's why we use the tangent formula. So it's not that we got negative radians that we need to move backwards. It's the fact that the angle is pointing into the quadrant that is not where our point is. So our point was in quadrant 2, but the angle is looking into quadrant 4. So I could have had a positive angle in quadrant 1, but if my point was in quadrant 3, then I'd have to use the backwards radius. Yeah. So here, let me scroll back up to the formula sheet. So yeah, they're right here on the bottom right. So yeah, we've got all the Pythagorean identities, the double angle, the half angle. You probably won't use the half angle. The sum or difference formulas. We have all 4 of them. You're only going to use one of them. I don't remember which one. Then we have law of sines and one version of the law of cosines, and then the polar formulas. Yes, so if the angle and the point were, if the angle was already pointing into the quadrant that the point was in, then we'd use the positive radius. Now, the other polar point we're going to get, or the other polar question, sorry, it's not a point, it's an equation. So we're given a Cartesian equation, an XY equation, and we're being asked to convert it to polar form. So we have x squared plus y squared equals negative 4y. So there's a couple of ways to work on this problem, but because it's a web work question, web work has an added amount of work we have to do. Web work needs the answer to be r equals by itself. On the test, you don't have to do this. On the test, I just need it converted into polar form. So when I'm looking at my formula here, x squared plus y squared equals negative 4y. I technically have a substitution for x and a substitution for y that are only in terms of r and theta. So I can just substitute both of those in and I'm done. But if I do that, it'll be a little extra work to solve for r. So I'm going to get a little more creative. X squared plus y squared. That sounds really familiar. Why is that familiar? What is x squared plus y squared the same as? So just the hypotenuse? But just the radius? Like it's just equal to r? R squared. So x squared plus y squared equals r squared is one of our formulas. So we're just directly changing out x squared plus y squared and we're putting r squared in its place. Now our y is the same as r sine theta. Now for the purposes of the test, done. That is a polar equation. There's no more x's, no more y's. For the purposes of web work, we have to do one extra step. It is a very stupid step though, like basically we can only do this step because we're dealing with polar points. So both sides have an r. So I'm going to divide both sides by r. Normally, we never, ever, ever divide by a variable. But in polar equations, when we're trying to simplify them down to r equals, we can do this. So we have r equals negative 4 sine theta. That is what we would type in for web work. Oh, sorry, they actually want the r equals. All right, now we've only got 20 minutes left. So what would you guys like to see next? We can solve a trig equation. We could do a law of sines or a law of cosines. Like the law of sines?
Yes, where you're gonna say, the three sides, and then you can figure out the angles from them to see that you have, there's another triangle inside the triangle.
So you won't have two triangles. It won't be the two triangle setup. Like the triangle will not produce two triangles, but it will look like that setup. It is an angle side side setup. And that's because when you solve a triangle that's angle side side, you have to use law of sines to find an angle, and then you have to use law of sines to find a side. And we want to see both calculations in the work. So it's only going to produce one really wide triangle. But on your web work homework, you do still have a double triangle case. So problem 13 is actually a two triangle case, but you only have to solve one triangle on the test. But this is the same glitchy problem from our 5.1 homework. So again, make sure to use angles that they're really close to integers, just round it to the integer, run the calculation with the integers. And then if it tells you that your answers are wrong, swap the top and the bottom answers. So the question is not going to ask you how many triangles it produces. It's just going to ask you to solve the triangle. It's not going to draw the picture for you, though. It's just going to give you the angle and two sides. All right, so if we start this problem out, I don't use the drawing they give. I draw my own. All right, so I draw a big horizontal side, a long diagonal, and then a short diagonal. And then the angle they gave me was beta. So that's the angle I put there. And that means the side opposite that has to be side B. So this is the 6.36492. And then the other side they gave us was C equals 10. So on the test, C won't be longer than B. C will be smaller than B. And that's what produces the one really wide triangle. But when C is bigger than B, this is where we have the two triangle case. Now the angle opposite C is angle gamma. If you want to call them A, B, and C instead, that's fine. It's just the formulas are given with alpha, beta, gamma. So you just have to know what the trade out is. So we are going to solve for angle gamma. So I'm going to start with the sine of gamma over C equals, and then I have the betas, so I'll have the sine of beta over B. So I don't know gamma, but I know C is 10. And then it's the sine of 37 degrees. And side B is the 6.36492. So now I would multiply by 10 on both sides. So I have sine of gamma equals, leave a space, 10, sine 37 over blah, blah, blah. To get rid of sine, we use the inverse of sine. So we're applying that on both sides. So I'm going to type in that calculation. Now, I need to make sure I'm in degree mode. So depending on where you are in the test, the order you do the problems, you're going to need to be in radians mode for the polar question, but you need to be in degree mode for the law of sines and law of cosines questions. All right, so I'm back in degree mode now. Inverse sine, 10, regular sine 37, close the little parenthesis, divided by 6.36492. And I get 71.000038. So we are going to call that 71 degrees. Now that I have that, I can go back and solve for alpha. So alpha is going to be 180 minus beta minus gamma. So beta is 37, gamma is 71. And we get alpha is 72 degrees. Now that I know alpha, I can solve for side A. So I'm going to start with A over the sine of alpha equals, and you can use the B's or the C's. I habitually go back to the B's because that's what they gave me to start with. So B over sine beta. So I don't know A, but I know that alpha is 72. So I have A divided by the sine of 72 degrees equals B is the 6.36492 over the sine of 37. So I multiply both sides by the sine of 72. And that's what I type in for side A. So I've got the 6.36492 times the sine of 72. I got to make sure to close the little parentheses before I divide by the sine of 37. And that gives me 10.058570. So that is how much work you'll have to do on the law of sines question on the test. You have to use law of sines to find the unknown angle, subtract from 180 to get the third angle, and then use that third angle to find the last side. Now for web work asks us to find the second triangle on this one. So whatever angle we found first, the prime of that initial angle is 180 minus that angle. So gamma prime 180 minus 71 equals 109. Then we could solve for alpha prime, and then we could solve for A prime using the same steps we did before. You won't have to do that part on the test because it's not a two triangle question on the test. It's just one wide triangle. All right, we had a request for trig equations. So I yoinked problem 9. So it's a little bit weird. We've got a 1/2 x inside the trig function. We're trying to get x by itself. So the first thing I'm going to get rid of is the one that's being minused. I'm going to add 1 to both sides. So I have -4 sine of 1/2 x equals -2. Next, I divide by the -4, so now sine of 1/2 x equals 1/2. Now, this is where I use the unit circle. So we're asking ourselves, where is the sine equal to 1/2? So the sine has a value of 1/2 when it is close to the x-axis. That's where the y value is short. So that is pi over 6. And then the other spot where the sine is 1/2 is at 5 pi over 6 in quadrant 2. Now, because these are angles from the unit circle, those are the starting value of an infinite list of coterminal angles. So we need the plus 2 pi k notation. Now, if you forget the 2 pi k on this one, it'll actually work out okay. I just habitually write it so I know where it goes and when it's supposed to go there. Now we have 1/2 x equals these two angles. So I need to get rid of that 1/2. So how do I get rid of 1/2 of x? Why do we multiply by 2? Yep, if we multiply a half by 2, it's going to turn into a 1. It's one of the ways we get rid of it. Some people also look at this and say divide by 1/2. That also works. Dividing by a fraction is the same as multiplying by the reciprocal. So that's why I'm writing times 2, just because it looks a little bit cleaner on the page. So pi over 6 times 2 is 2 pi over 6, which becomes pi over 3, plus 2 pi k times 2 is 4 pi k. Then 5 pi over 6 times 2 becomes 5 pi over 3, plus 4 pi k. So it turns out the 4 pi k, like if I pick k equals 0, I get the two numbers I see. I get pi over 3, and I get 5 pi over 3. So I got those two solutions. If I pick k equals 1, I'm going to be adding 4 pi. That's going to be way bigger than 2 pi. If I put in k equals -1, I'd be subtracting 4 pi. That'll get below 0. So we don't need to use any other k values. They would be too big or too negative. So the only two solutions are the two solutions we got just from following our normal procedure. So it's a little bit different. Most of the equations we looked at in the past, it was like sine of 2x or sine of 3x. And when it's a bigger number times x, that's where you have to use k values. But here, since it's a number smaller than 1 times x, we actually end up with infinite lists that are further stretched apart. So there's the possibility of fewer answers. Now you're also going to have one on the test that is quadratic. So problems 10 and 11 are good practice for a quadratic one. Now, I recorded a video yesterday of my Tuesday, Thursday class, and I actually had the time to do this problem, like factoring and also showing like where the quadratic formula would fit in if you're not comfortable factoring. And I did post the link to that video. So on the test, no, you won't need to use K values. Like the negative K value here, pi over 3 minus 4 pi is going to be very negative. 5 pi over 3 minus 4 pi will also be negative. And our answers are restricted to 0 to 2 pi. So we don't need to use K values here. Those numbers won't be between 0 and 2 pi. Yeah, we only have a few minutes left. So what other like last minute structural questions do you guys have? There will be a law of cosines question. It will be a word problem. Yes, the second trig equation is a quadratic. The polar coordinates?
Yeah.
The other one they give us is in quadrant 1, but we can work that out. Like problem 19. The homework for 5.3 has more practice problems on this. But yeah, we could do this one real quick. All right, so we've got X and Y. We need R and theta. So we're going to use X squared plus Y squared equals R squared. And we'll use the tangent of theta is Y over X. So we have 1 squared plus 7 squared equals R squared. So we have 1 plus 49, which means R squared is 50. And then we square root, and I'm going to leave it plus or minus for now. Now I fill in my Y over X, so tangent of theta equals 7 over 1. And now I'm going to use inverse tangent. Now this is going to be an ugly number. There's no way to make it be a pretty number. And we do need to make sure we're in radians. So inverse tangent of 7 divided by 1. Well, we have to pick if we want the positive or the negative radius. So this is where we actually look at the ordered pair. The point is 1, 7. So that is a quadrant 1 point. So our theta is positive, so that's already looking in quadrant 1. So we're going to use the positive radius, because we want to go forwards from that angle location. So it'll be positive square root 50, comma 1.42889. All right. Now I'm just gonna have to like exit Zoom to get the recording to stop. Yep, see you on Monday.